addition. It means we have to show that matrix addition is commutative, associative, existence of identity and existence of inverse. The first one is let Aij of n cross n matrix B whose second element is Bij n cross n and matrix Cij of m cross n. These are three matrices of the same order. Then we have the following properties. Then we have the following properties. Number one, commutative law. Commutative law, it means commit A plus B is equal to B plus A. Matrix addition is commutative. If you have to show that, you take the left hand side is equal to A plus B. It means Aij plus Bij. You get by matrix addition corresponding elements are added Aij plus Bij. Its order is n cross n, its also order is n cross n, therefore its also order is n cross n. And addition on the real number is also commutative law holds, so you can write here Bij plus Aij. This can be written as Bij plus Aij. Okay, this is matrix B and this is matrix A. So matrix addition is commutative. It means A may be added to B and B may add to B, result is the same. So this is the commutative law. Now next is the associative law. Second one is the associative law. Associative law. Matrix addition is associative. It means A plus B plus C is equal to A plus B plus C. It means resultant of B plus C with addition of A or resultant of A and B added in C, result is the same. This is the associative law. Associative law, it means matrix addition is associative. And third is existence of identity. This is very important. Existence of identity. It means अगर आप जिस सेट की बात कर रहे हैं उस सेट का कोई भी नंबर चूज करिए. जैसे यहाँ पे हमारे पास सेट क्या है, मैट्रिक्स. आप नंबर सिस्टम में जाइए तो उसमें हमारा सेट क्या है, इंटीजर. तो आप कोई भी इंटीजर चूज कर लीजिए और वहां पे आपको ये सर्च करना है कि ऐसा कौन सा इंटीजर है जो किसी भी इंटीजर में ऐड करने पे अगेन यू गेट द सेम रिजल्ट्स. तो फॉर एग्जांपल इफ यू टेक एनी इंटीजर, सपोज यू हैव टेक 5. नाउ यू हैव इंटीजर 0. You add 5 plus 0 or 0 plus 5. Again you get the 5. Therefore 0 is the additive identity. Exactly on the same way here in the matrix case, for any matrix A, there exists a null matrix which represented by a capital letter O. A plus null matrix is equal to null matrix plus A. Since matrix addition is commutative, again you get the A. Therefore, null matrix is the additive identity for matrix A. This is the additive identity for matrix A. कोई जरूरी नहीं है कि हर सेट में हर ऑपरेशन के लिए आपको आइडेंटिटी एग्जिस्ट करे। मान लीजिए सपोज सेट आपका है नेचुरल नंबर और ऑपरेशन आपका क्या है एडिशन, तो वहां पर कोई भी ऐसा नेचुरल नंबर नहीं है जो किसी भी नेचुरल नंबर में आप ऐड करें तो अगेन यू गेट द सेम नेचुरल नंबर। सो इन द केस ऑफ नेचुरल नंबर एडिशन हैविंग नो additive identity. Okay, next is existence of inverse. Existence of inverse. Fourth case, existence of inverse. In the case of inverse, you have to see that for matrix A there exists another matrix like negative times matrix A, or you say that negative times matrix A plus A gives the additive identity O. Therefore, negative times matrix A is the additive inverse of A and vice versa. Okay, it means inverse existence find करना है तो आपको सेट का कोई भी मेंबर चूज करना है और अंडर द ऑपरेशन आपको एक ऐसा मेंबर चूज करना है जो उसकी करस्पॉन्डिंग आइडेंटिटी दे। अब जैसे मैट्रिक्स के केस में हमको पता है कि हमारी एडिटिव आइडेंटिटी क्या है, नल मैट्रिक्स, तो हम एक ऐसी मैट्रिक्स ऑब्टेन करेंगे जो किसी भी मैट्रिक्स में ऐड करे हमको रिजल्ट क्या मिले, नल मैट्रिक्स, तो दैट इज द नेगेटिव टाइम्स मैट्रिक्स। तो अगर ये मैट्रिक्स A है इट्स एडिटिव इनवर्स इज नेगेटिव एंड मैट्रिक्स नेगेटिव टाइम्स है इट मींस इट एडिटिव इनवर्स इज A। These are following properties for addition of the matrix. Now properties of scalar multiplication. Scalar multiplication, let A and B be two matrices. Suppose A and B be two matrices of the same order, like M cross N. A and B the two matrices of the same order. Now we discuss properties of scalar multiplication. So A and B are two matrices of the same order and K be any scalar. Then first is K times A plus B is equal to K times A plus K times B. First property. Second is K1 plus K2 times A is equal to K1 times A plus K2 times A, where K1 K2 are scalars. And third one, K1 K2 times A is equal to K1 times K2A or K2 times K1A. These are properties of the scalar of multiplication. Okay. Now student, next operation is multiplication of matrices. This is very important step for multiplication of matrices. You have to see addition, subtraction, scalar multiplication, but multiplication of matrices is very important. So first of all, whenever multiplication of matrices is exists, matrix multiplication is possible only when number of column of first matrix equal to number of rows in the second matrix. Okay. If, for example, any product of two matrices A and B, you can say that product of two matrices A and B denoted by AB. It is possible only when firstly check the system. If you multiply matrix B in A, of course number of columns of A is equal to number of rows of B. Suppose let A is equal to Aij of order m cross n, and G is a matrix BJK of order n cross B. You see that number of columns of matrix A is equal to number of rows in matrix B. It means product of matrix A B adjust. Okay, so therefore product AB is equal to, whenever you multiply matrix B with A, it means Aij of order m cross n to matrix BJK of order n cross B. You get another matrix Cik whose order is n cross P. Number of rows of the first matrix and number of columns of the second matrix. It means firstly you see that product exists or not. Whenever product is exists, when number of columns of the first matrix equal to number of rows of the second matrix. If this exists, then resultant matrix having the order number of rows of the first and number of columns of the second. So its order is n cross P, and where Cik, its element Cik is equal to sum of summation j is equal to 1 to n Aij BJK. Sum of multiplication of first row with corresponding elements of the first column of the second matrix. Then you get these sums. It means Ai1 B1k plus Ai2 B2k and so on. Okay, this gives this result. For example, suppose A is equal to matrix A is 6 9 2 3. Its order is 2 cross 2. Of course, matrix B having 2 rows 2 6 0 7 9 8. Its order is 2 cross 3. Of course, product matrix AB has the order 2 cross 3. The product AB adjacent number of column of matrix A is equal to number of column of matrix B. Therefore, AB defined. Or you say that AB adjacent product of multiplication exists. And how to find the product of AB? First you take first row R1. And here take the first column of matrix B, and now you multiply the corresponding elements of first row of A and first column of B and take the sum. Like this, 6 into 2, 6 multiplied by 2 plus 9 multiplied by 7. This is the first element. Okay, here we write this is suppose product of matrix AB represented by C. So we write here Cik. It means C11, C12, and how many columns are here? P. So C1P. Okay. And how many rows are? N rows. CM1, CM2 up to CMP. Okay. So this is the C1. And exactly in the same way, first row multiplied by the by 6 plus 9 multiplied by 9. This is the second element of the product matrix. Similarly, you multiply the corresponding element of the first row of A and third column of B like this: 6 multiplied by 0 plus 9 multiplied by 8. This is completing the first row of A, and exactly on the same way you multiply second row with first column of B, then you get the C1, and again second row from second column of B, and then second row of A with third column of B like this: 2 multiplied by 2 plus 3 multiplied by 7, 2 multiplied by 6 plus 3 multiplied by 9, 2 multiplied by 0 plus 3 multiplied by 8. Okay, now simplify. 6 2 is 12 plus 9 7 is 63. 12 plus 63, it means 75. 6 6 is 36 plus 9 9 is 81. This gives 117. And here is 0 plus 72. It means 72. And here 7 3 is 21 plus 4 25. And here 9 3 is 27 and plus 12. It means 39. And here is 24. And you see that its order is 2 cross 3. This is the product of the matrices. Okay. This is the procedure for finding the product. Now next is positive integral powers of a square matrix. If we multiply the square matrix by itself, we get the positive integral power of the square matrix. That is, for any square matrix A, we get A raised to the power 1 is A raised to the power 2 is equal to A multiplied by A raised to the power 3 is equal to A raised to the power 2 multiplied by A. Similarly, A raised to the power 4 is equal to A raised to the power 3 into A, and A raised to the power n is calculated as A raised to the power n minus 1 multiplied by A. This is the positive integral power of this square matrix. Now matrix polynomial, that fx is a polynomial in X, right? Fx is equal to a0 x raised to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 up to an minus 1 x plus an. This is the matrix polynomial of degree n. Okay, is a polynomial in X, and A be any square matrix of order n. It means n cross n. Therefore, f of A represents the matrix polynomial like a0 a raised to the power n plus a1 a raised to the power n minus 1 up to an minus 1 multiplied by matrix A plus an times identity matrix of the same order of the given matrix A. Here A is the square matrix of order n, so here we take in I is the identity matrix of the same order n cross n. This is the matrix polynomial. On this, we take one example also. Suppose A is a square matrix 0 1 1 2, and fx is equal to x square. Let A be square matrix and fx is equal to x square plus x minus 1. Find f of A. For finding f of A, we have f of x is equal to x square plus x minus 1. Therefore, f of A calculated as a square A multiplied by A, and this is equal to 0, 1, 1, 2, with itself 0, 1, 1, 2, and if we multiply A with A, you again see that here multiplication is axis, since its order is 2 cross 2 and its also order is 2 cross 2. First row of A multiplied the first column of A. So 0 plus 1 into 1, we get the 1. 0 multiplied by 1 plus 1 multiplied by 2. It means sum is 2. Similarly, here the procedure 1 multiplied by 0 plus 2 into 1, we get the 2. 1 multiplied by 1 plus 2 into 2, which means 5. So we get A square is a matrix 1, 2, 2, 5. Now find f of A. F of A is A square. A square means matrix 1, 2, 2, 5 plus A is 0, 1, 1, 2, and identity matrix is 1, 0, 0, 1. Now corresponding elements are added or subtracted. It means 1 plus 0 minus 1, 2 plus 1 minus 0, 2 plus 1 minus 0, 5 plus 2 minus 1, and you get 1 minus 1, 0,